Hello to each and every one of you, grade 12s. Welcome back into our lesson video. So today I want us to look at geography, drainage patterns. So we're going to be discussing drainage patterns. All right, so you know that drainage patterns are some form of a drainage basin. So this basically means that a drainage basin can form in various ways or can form in various patterns, which we are going to discuss today. So this is our topic today. Okay, all right. So the very first pattern that we're going to be discussing is parallel drainage pattern. So each and every pattern that we're going to be discussing today has the requirements, the characteristics, as well as the example. By the way, the examples, you can add up more of your own examples, okay? Through your own imagination or through your own experience from what you know where you're coming from, okay? All right. Let's start with the requirements and the parallel drainage pattern. The requirements is that it must be recently uplifted sloping plane. What does that mean? Look, can you see? Okay, so look, this is the mainstream, okay? This is the mainstream, okay? Yes. And these small streams that are joining the mainstream, as you can see, are tributaries. Okay, yes, which are joining together, so I mean that which are joining there, the mainstream, okay, yes, so they pour water to this mainstream. The tributaries are originating from the upsloping hill. That's an example, okay, yes, from the upsloping hill. So this is they originate from the upsloping hill, so I mean that our tributaries originate from the upsloping hill, so I mean that this landform here is a hill-like or is a high-lying area, okay, yes, so they move down with water, so tributaries move down with water to join the mainstream. So that's how that's one of the main requirements, okay, yes. Let's move on. So the rock type uniformly resistant to erosion. What does that mean? So I mean that the other parts of the underlying rock structure of this landform is, so other parts can be eroded and other parts, so mean that the bulk parts cannot be eroded. What does that mean? Look guys, because in most students this is very, very confusing. The underlying rock structure underneath this landform of a parallel drainage pattern, the rock structure can allow water to erode in joints. So meaning that the underlying rock structure has joints, okay? Please guys, have joints, all right? Yes, so that's what it means when it says uniformly resistant to erosion. When a rock is uniformly resistant to erosion, that's what it means. So this basically means that the tributaries as well as the mainstream has formed in a result of the eroded joints of this underlying rock. So let's say we have a rock, okay, a big rock underneath, so mean that there will be a joint, okay, a joint at this particular point and a joint on the other side, okay, and the joint on the other side. I hope you understand what I'm trying to explain to you, okay? Yes, so I mean that the water will flow through, will erode and flow through the joint to form streams. I hope you understand guys, and that's it. So the rock, yes, I've explained that, okay? Yes, so let's move to characteristics. So when you talk about the characteristics of a parallel drainage pattern, the mainstreams flow parallel to each other, all right, or they are near to each other, okay? Yes. What does that mean? Let me just make a drawing of the landform, okay? Yes. Look, let's say we have a landform like this. So this is the riverbed, and on the side it starts to uplift, so I mean that it's a sloping plane, okay? Yes. And also on the other side, let's say we have, and it starts to be gentle on the other side, something that you have a riverbed, okay? Yes. So it's also vice versa, okay? Yes. So it continues in that particular way, okay? Look now, when they are parallel to each other, this basically means that there will be water inside, right? Yes, there's water inside. This is the mainstream, okay? And also mainstream, okay? Yes, flowing this way downwards, okay? Also flowing this way downwards. And the tributaries moving from upsloping hill or from a sloping plane, okay? Yes, that's how it goes. So these are the tributaries, okay? Yes, so we can see that our mainstream are parallel to each other, okay? Our mainstreams are parallel to each other. That's what it means, okay? Yes, so that's what it means. Or they are nearly to each other, okay? Yes, so mean that they are divided by this slightly uplying area, okay? So the tributaries enter the mainstreams at very small angles. As you can see, this is a small angle, okay? Yes, at very small angles, okay? That's how it goes. At very small angles. The tributaries in a parallel drainage pattern join the mainstream at very small angles. Very, very small angles. As you can see that these angles, or the angles at which the tributaries join the mainstream, is not wide, okay? Yes. An example of these tributaries of the Steelport River in Limpopo. An example of this, okay? Yes, you can also have your own examples, okay? Let's move to the dendritic pattern, the most common one. So it's the most common, guys. The dendritic pattern is the most common. So the requirements, the rock is uniformly resistant to erosion. So the rock structure also is uniformly resistant to erosion. So our tributaries has formed through the joints of this underlying rock, okay? So the pattern is not dependent on geology. So this basically means that, let's underline that, it's not dependent on the geology. So this basically means that a dendritic drainage pattern can form at any kind of a landscape or of a landform. There are no like critical requirements, okay? It can form at any kind of geology or landscape. That's what it means, okay? Yes, it doesn't depend on, for example, for a rock structure to be uniformly resistant to erosion to form. It can form at any kind, okay? Yes. All right, so let's talk about the characteristics. So when you talk about the characteristics, so the pattern is tree-like shaped. So as you can see that the pattern is tree-like shaped, as I told you that it's very common. Even if I'm drawing a drainage pattern for you, you can clearly see, or I'm just going to draw something that's similar to a dendritic pattern, okay? Yes, so it's tree-like. So I can say these are kind of small branches as tributaries, primary tributaries, as well as secondary tributaries, joining other tributaries, and I can say this is a main branch, okay, of a tree. So you can clearly see that it's a tree-like, okay, dendritic pattern. All right, hope you understand that. The tributaries join the mainstream at acute angle. So the tributaries join the mainstream at acute angle. An acute angle is an angle that is less than 90 degrees. So mean that the angles at which the tributaries join the mainstream are less than 90 degrees, which is an acute angle, as you can see, okay? Yes, so the angles less than 90 degrees, okay? Yes, so they're less than 90 degrees, okay? Yes, so that's how it goes. Let's say this is 90 degrees, so that's so they're less than 90 degrees. So the main streams, so let me just say these are the streams. Okay? The streams join, so at an angle that is less than 90 degrees, at an acute angle. I hope you understand that, guys. So an example of this is the most rivers in South Africa. As I told you, that is very common, and even if I told you to write down or to draw, or if I'm drawing for you a drainage basin specific to show you just an imagination, I'm just going to draw something similar to this of Dtic drainage pattern. So for example, Tugela Moi Umgeni. All right, let's move down. You have your own examples. So let's move to trellis drainage pattern. So when we talk about a trellis drainage pattern, look guys, a trellis drainage pattern, the requirements for it to form is that the parallel ranges of fault mountains or alternative layers of the hard rock and soft rock. So let me make an example of this. So let's say we have a landform that is like this. A landform that is like this. So in this landform, we have various parts of the underlying rock that are soft. So let's say this part is soft. Okay, yes. Let me just say this part is soft. Okay, mean that it allows to be eroded. Okay, yes. And also let me just remove that so that I can shade with blue. Okay, yes. So that I can shade with blue. So sorry. All right, let me just use that blue. So meaning that this allows water. So this rock it allows water to run through, okay, to form a river. Okay, yes. So meaning that this rock is a soft rock. It allows erosion to occur. So the other parts of the rock are not, or doesn't allow erosion. So let's say also this part is a soft rock. Okay, yes. So the blue parts, guys, are just soft rocks. So I'm just trying to show you this, okay, in this kind of way. Okay, so it's going to allow water to run through to form a river or a stream. All right. Also, this part of the underlying rock is soft. It allows water of the streams to run through. So that's how it goes, guys. So it's like this. So these kind of parts in between are rocks that are resistant to erosion. This part is a rock that is resistant to erosion. Okay, it doesn't allow erosion to occur or to simply occur. That's how it goes. So let's move on. I hope you understand that idea that is being emphasized at this particular point. So so it has a strong mainstream. As you can see that this tributary is very, very long. It's a very, very long tributary. So the mainstream it is going to be obviously strong. Okay, yes, with high discharge or with great discharge. Okay, yes. All right. So the main pattern is dependent on the relief and the geology of the area. So in order for a trellis pattern to form, these requirements must be met. So mean that the underlying rock should be composed of soft rock as well as ridges of resistant rock. All right, yes, that's how it goes. So let's move on. Let's move to the characteristics. So in terms of the characteristics, so the tributaries meet the mainstream at right angle. So you can clearly see that this is a right angle at 90 degrees angle. At 90 degrees angle. Okay, yes. So at the right angle at 90 degrees angle. Okay, yes. So they meet. So tributaries meet the mainstream at 90 degrees angle. That's the characteristic. You should know these guys. Okay, you should nail them into your head so that you can remember during the exam, as well as into becoming creative to remember them. The mainstreams cut gaps through the mountains. So as you can clearly see that the mainstreams are cutting through the high-lying areas. So this is a high-lying area, this is a high-lying area, and this is a high-lying area. Also on the description that I've shown you, this is a high-lying area, this is a high-lying area, this is a high-lying area, and this is a high-lying area. Okay, yes, and that's how it goes. I hope you get that. So an example of this is Bafels River at Lensbeck. Right, yes, that's how it goes. Let's move on, guys. Let's move downwards. So a radial drainage pattern. when you talk about radial, okay, so just before I move on, guys, please don't confuse radial drainage pattern with centripetal pattern. A radial drainage pattern, this is whereby the streams are from, so mean that the streams originate from a high-lying area to a downslope, so to general areas. All right, and the centripetal, this is whereby they are coming from, yes, I mean that they are also coming from the top to down, but a centripetal, this is whereby they're moving inwards. Okay, yes, but we're going to discuss that. Okay, yes, a radial, they move outwards. Okay, yes. So the requirements for this to form is dome-shaped hill. So we should have a dome-shaped hill. So mean that around this we have a dome-shaped hill. So mean that as you move down, we're decreasing with an altitude. As we move down, we're decreasing with an altitude. As we move down, we're decreasing with an altitude. As we move down, we're decreasing with an altitude or with heights above sea level. So this is a hill. So you know that also a stream starts from a high-lying area. So they start flowing from high-lying area downwards, but outwards now. Okay, yes, outwards. Okay, to different areas. All right. So the characteristics. The streams radiate outwards from a central high point. So the characteristics of radial pattern or drainage pattern is that the streams radiate outwards from a central high point, as I showed you there. So they are coming from a same point, which is high point, a hill, downhill, and move downhill. So let's underline outwards there. An example of this is a coffee bus as well as tubers. Okay, yes. So you can also have your own examples. All right. Let's talk about a rectangular drainage pattern now. So a rectangular drainage pattern, the requirements for it to join is that the well-jointed rocks with joints exposed at the surface. Now, there's no need for much erosion to occur because the rocks the joints of the rocks are being exposed on the surface or above the surface. So it's easy for surface runoff to form a pattern or a river. All right, yes, that's how it goes. So the joints exposed at the surface. So the characteristics, so rivers flow in exposed joints. As I explained that, I think you also understood in that way. Okay, yes. So let's say this is a joint of a rock, and this is a joint, and this is a joint also this side. So it means that water will flow through these red joints. Okay, yes. So these joints, so water will flow through. Okay, yes. Water will flow through, as you can see. And that's how it goes, guys. I hope you understand. Rivers and tributaries. Okay, rivers and tributaries have right-angled bends. So the rivers and tributaries, so let's say this is the river, the main river, and these are kind of tributaries. So they have, or the bends, as you can see, the bend here is likely to be the right angle, which is 90 degrees bends. Okay, yes, a 90-degree bend also there, a 90-degree bend also there. So that's one of the main characteristics of rectangular pattern. So an example of this is rivers in Waterberg in Limpopo. All right, let's move down. So let's discuss centripetal pattern, drainage pattern, which I already told you about before when we were discussing radial pattern, so that you don't confuse the two. Look, this is a highlying area on the sides of this lake. Okay, we have a lake inwards. So outwards, we have high-lying areas. So we can clearly see that these small tributaries that are joining to form this lake are originating from high-lying point or from high-lying area. All right, yes, that's how it goes. So my arrows show this is a high-lying area, guys. Okay, I mean that as you move up, it's increasing with the height above sea level. Okay, so a requirement is that a central basin or a low-lying area such as a lake or a marsh. Okay, So, or a dam even, okay, yes, or a lake in most cases, guys, okay, yes. So look, so we have a lake inwards, okay, yes, which is being formed by these tributaries that are from the highline area outwards, okay, yes. So an example of this, if ever I can draw for you, it can be something like this. We have a hill, this, we also have a hill this way, also have a hill this way, uplying area. So water will move inwards from this uplying area, move inwards from this uplying area, inwards from this uplying area, and inwards from this uplying area, okay, yes, to form a lake inwards. I hope you understand, guys. That's how it goes. So the characteristics: streams radiate inwards, as you can see. Streams radiate inwards from high-lying points, okay, yes, from surrounding high area. The opposite of a radial drainage pattern, as I told you. Don't confuse the two, okay? Be careful. An example of this is common in the flatter parts of Namakwa land. That's how it goes. Okay, yes, because Namakwa lands have many high-lying areas that are being formed in this kind of geology, okay? Okay, so let's discuss deranged pattern. So when you talk about deranged pattern, the first thing that I have to tell you is that deranged patterns are most likely to be found in areas that have glacier as well as snow, which are close to North Poles and South Poles in most cases, guys. That's how it goes. So the requirements for it to form: geological young areas, okay, yes. So when you talk about the characteristics, haphazard pattern, so mean that the pattern doesn't make sense. It has a lack of plan, okay, as you can see that this is a tributary, as you can see, and it forms something like a dam-like, okay, yes, which is wide. Also, this tributary sends water to this side. It forms something like a dam-like. Also, it sends water to this side, which doesn't allow water to continue to flow. So the pattern doesn't make sense, or the pattern does not have a proper plan. That's what it means. Okay, so in this case now, so that you can be able to answer during your exams or during your test, look, the last round part or the last dam-like part that is being transported water to mean that it's going to be the one that has most volume of water inside. So let's say this part is transporting water to this part, as also this part is transporting water to this part. So mean that this part is going to acquire or is going to have a great volume of water inside it. I hope you understand what I'm trying to say. Streams, okay, so an example of these can be numerous lakes as well as swamps, okay, yes, lakes and swamps. So streams enter and leave swamps and lakes randomly. As I told you that they just leave them randomly. It doesn't make a proper plan, okay, or a proper sense. Example, so an example of this can be a recently glaciated areas such as the Canadian Shelf. So as I told you that these kind of deranged pattern mostly form in glaciated areas or in areas that have snow. So when the glacier melts, so when it melts, so it's going to form these kind of patterns, so mean that water will start to move to stack to these kind of areas and send water to the other one. As you can see also, it doesn't make sense, okay, yes. So I think that's it, guys. So that's the end of our lesson video today. I think I've tried to explain. Have a great day. Cheers. Don't forget to subscribe. Thank you.